But you guys help me out here. Let's see if we can do this without looking at anything. So I will write down the quadratic formula because you really do have to have it memorized in order to do it this way. So let's pretend like this is what's in your head. Negative b plus or minus square root of b squared minus 4ac all over 2a. Eventually it will be in your head. Okay. Now let's just fill it in and simplify as much as we can as we go. So what's negative b? So x equals negative 2. That's the opposite of b. Plus or minus b squared. What's b squared? 2 squared is 4. Minus 4 times a times c. What's a? 3. What's c? 4. And underneath, all over 6. 2 times a is 6. Okay, so what are we going to have underneath that radical? Oh, I don't know. What's 4 times 3 times 4? So we get 4 minus 48 underneath the radical. What's that? Negative 44. Negative underneath the radical. So what do we do when we have a negative underneath the radical? We poke out the I and we simplify the root 44 as usual, right? Can we do that all at once? Or at least as scratch work maybe? So negative root 44 you told me is I radical 44, right? Poke the I out. And then how does root 44 simplify? So 4 times 11 is 44, right? You can pull out the square root of 4, which is 2. 2i radical 11. So simplifying these radicals just becomes part of a bigger problem, right? Okay. So, can we simplify this one? I guess the theme, I didn't mean for it to turn out this way, but it looks like in just about every problem you have to factor out a 2 in the numerator. Sometimes you can't factor out anything. Sometimes you factor out something other than 2. Don't get the impression it's always 2. It just worked out that way. You know, as a teacher, you pick problems to do, and you don't necessarily think about those patterns that develop. Factor out the 2, what's left? Negative 1 plus or minus I root 11 over 6. And what is 2/6 reduced to? 1 over 3, or just 3 in the denominator. So we end up with negative 1 plus or minus I root 11. I times the square root of 11 is what that means. All over 3. That's a good way to leave it. So, in other words, the solutions to this equation are complex, right? Yeah. There's nothing wrong with that.